So O-Mopsi is a secondary app that we made with data collected from the Mopsi app. So inside the Mopsi app, you can take, for example, picture of photos, geotagged photos, and they are going to be collected in your own collection. Well, O-Mopsi is a game, and this game is going to be very similar to orienteering, this O-Istus in Finland, where you have to find a set of targets as quickly as possible. The only difference from orienteering is that you can go in any order that you want. So in orienteering, you are getting a specified path, and here you can choose what order you want to reach the targets in. It will become a bit clearer as we check it out. So this O-Mopsi contains many game instances. So all of these things here in this list are different games created in different parts of the world. Most of them are going to be in Finland, but there are also some in other countries and cities in Europe. Most of them, however, are in Finland, and the highest majority is the biggest majority is going to be in Joensuu. Okay, but each of these are game instances, so you can choose one and play it. And after you play it, after you start the game, there will be a set of targets, like these ones here, that you have to visit as quickly as you can, as quickly as possible. So each of these targets has a picture. The picture is coming from the Mopsi data collection. And a location. The location also comes from our database. Now, of course, when you think about choosing an order to visit a set of targets, you should immediately think about this traveling salesman problem. And some of you even had projects with this traveling salesman problem, related to the traveling salesman problem. So you could compute this kind of optimum tour, but we don't give this information to the player. So the player has to figure out the tour himself, the order to visit the targets. And what happens usually is that if we look in the results, some people have decent results, so this is actual tracking trajectory, but some people have a bit less optimum results. So if we look at the distance here, this person had 2 kilometers, 400 meters, and the first one had 1 kilometer, 500 meters. So it's almost 1 kilometer difference in the length that these two people had to travel. So the game is not just about being fast, but it's also about being smart, figuring out what is the optimum order to connect the targets and at the same time reach them quickly. Spending too much time on thinking may make the ones that are fast be above you in this ranking list, but not thinking enough doesn't matter how fast you are, because you might start to make mistakes. Okay. So, yeah, so this is how different people have played and their rank here. And you can always compare it with this optimum tour. So here the optimum order found by computer says, essentially it says that this link here should not have been taken and that the start location should be somewhere else. Now, I don't actually remember where some of the features here are, but I think that But I think that this one maybe game reviewer maybe not. Okay, so here Lahari is doing her PhD on this TSP-related things, and she is calculating different issues with this playing. So she finds that this playing has a mismatch of 1, and that mismatch is this link here. So this link was not taken by the person, even though the person should have taken that link. So some statistical properties of how good the playing was is also calculated, not just this time ranking, but at the moment we don't know how to make a better scoring than the one by time. So combining these two is not straightforward. So is the order more important, or is the time more important, or do you combine them somehow? And if you combine, how do you combine them? It's not obvious. But Lahari, what she is trying is to also have an alternative ranking. So here, second ranking, same people, but they are now ordered by how many of these mismatches are present between their path and the optimal path. So some player was the top in that variant, and actually same player is in the top in this other variant. So you could say that this, oh no, it's not, sorry. So that is E here, letter. So this player, even though he's somewhere in the middle of the list, has a better order of visiting the targets. You could choose in this type of game to reward both people, somehow give them some kind of a trophy or whatever for being top in either of the lists. This is a good strategy because people like to get stuff. They like to be top in something. And if you have multiple top lists, then more people are going to feel good. So instead of combining them and figuring out a scoring function, a combined scoring function, having multiple ones may be the easier solution, but also better for usability. I don't know. But that's what we do now. Okay, let's try some other game and see how the results may differ. This interface for some reason doesn't let me go all the way down. Let's see. So this is a wider game. The other one was used in SciFest. It's a festival where usually kids are coming. It's hosted in this arena building every spring, just behind the science park. But this one is some game that I created, and only a few people played. But it's a larger area. So instead of being just here in the middle of the city, in the university area, this one is everywhere. So it's all around Joensuu, and some people have played it. At least Pasi played it. It took him about 2 hours to do it, and Jukka also played it, and some other user also played it. So you can see how the path that each of them is taking is different, and also the distance and the time is going to change for each of them. So Pasi had to go 20.5 kilometers, while the first person less than 20. Right. And the ordering is also a bit different here when comparing to this optimum order, visiting order. Okay. This actually seems to be pretty good. So I'm not sure why he doesn't have 0 errors there. Don't know, but I think it's possible that this mismatch criterion might have changed meanwhile. So maybe it's not anymore just counting the edge, but somehow differently. I'm not sure. That's what happens usually. So Lahari is always trying to find better ways of measuring something, and actually you guys are also doing the same. So in the projects that you had this traveling salesman recalculating task, that can be also seen as a measure for how well did the user play. Because having this counting the number of mismatches can be not so meaningful as measuring how many times you have to recalculate. So every time you are making a mistake in your game and it needs the algorithm to recalculate, you own that mistake. And the remaining path is going to be optimum, but it's going to be optimum assuming the mistake that you have already done. It might change the configuration completely. So that means that you won't have the same mismatches necessarily anymore. And you can assign a penalty for this mistake. How you assign the penalty, it can either be just a binary case, or you can take into consideration how big did the path become after recalculating. So then you could have a big mistake or a small mistake. So actually, I think Lahari already has this implemented somewhere, but time to refresh the page. When it's not responding, I don't know what else to do. So, okay, when it's really not responding, time to go to the incognito window and try it there. And then it's responding. Okay, sorry?
Why does it respond in incognito window?
Good point. So some of the algorithms that are used here in O-Mopsi are heavy ones.
Okay.
They are for solving this kind of traveling salesman problem or whatever. They could be optimal ones, which are really demanding, especially for larger games like the one I loaded before. When I press some of those buttons there, I don't really know what happens, how those mismatches, how those mistakes are calculated. It might call some of these algorithms. And it will start a session where that algorithm must complete until the web page is going to respond again. And the problem is going to be that, the solution here is that if I open in incognito mode, there is going to be a new session created. So a new thread is going to be allocated for that.
Okay.
These problems shouldn't happen. You should always have some kind of timeout or some checking. Is the input too large for some specific algorithm? But we are not that good. I mean, we should handle these things better, but It's just not enough power, like human power, to take care of all these different things. But that's why it happens. Okay, and yeah, there is also a measure of game complexity here. So this is quite the interesting aspect. So what is an easy game and what is a hard game? What do you think? What do you think makes a game easy and hard? What features?
The shape of the
Shape.
yeah.
Okay.
The solution.
Sorry?
Yeah, of the solution.
Mm-hmm. Anything else?
The distance between.
The distance. Do you mean distance because the person has to run farther, or do you mean distance because...
No, because if you have a big distance between two targets, you may have many more choices to go from A to B. You may have different paths, so you will increase the distance maybe a little bit. It can be just 10 meters, but still it will not be optimum.
Okay, I think I understand what you mean. Correct me if I'm wrong. If you have two targets and one is here and the other one is here, you basically could go this way or you could go this way.
Yes.
So the longer the distance, because of the road network, you may have multiple similar options and you could choose the wrong one. So an additional source for a mistake.
Yes.
Yeah, very good point. If the game would be here, after a month or so, it's going to be frozen, so you could have the game on the lake.
Okay.
Would the distance still be a problem?
Mm.
I mean, if the obstacles are not there or no roads, you can just go anywhere. Does the distance issue disappear? Maybe. But yeah, so the complexity of the city or the area is also going to affect. That's more or less what we are talking about. Okay. How about number of targets? For algorithms, it's the thing that usually grows the complexity. Like algorithms start to be slower and slower for larger number of targets. How about for humans?
Yeah, it will take more time to go to the next target, but not also more time to calculate the shortest path for human. More mistakes can be done.
Okay, yeah. So indeed, it's a combination of all of these, and I have to say I don't remember how this number was calculated again, but I agree with it on several times. For example, complexity here for this game is 5.64, and if we load some other game, maybe this one, complexity is 0.67. Why is this game easier? And yeah, I assume this is some zoo or something, and that I guess those are the animals that you visit. So why is this layout easier than the other one? It's yeah.
And there are less targets, and the shortest path is obvious. It's nearly a circle. It's a C.
Obvious.
Yeah, nearly. We just draw a circle and we remove the longest one.
This one.
Yes.
So you have like a letter C that is reversed. Yeah, okay. If I remember right, yeah.
Do you know how to interpret?
Can you repeat?
Do you know how to interpret the complexity number? So
Yeah, so I think I know how to explain how this complexity is calculated, but I am not exactly sure. So I'm going to show you some other things related to complexity. I think this number is calculated somehow by simulation. It tries to find the optimum starting in this point, in this point, in this point, in this point, in that point, and that point, and computes the number of mismatch links on average. So here the number is small because it doesn't really matter where you're going to start, you will still have one mismatch link in the worst case. But in the other variant it was more complicated, so the value was growing. But now I want to talk about something that you pointed out. And oh yes, I can't believe it. It's a year until I open this page. Okay, ignore now some things here. This is minimum spanning tree. You might know what the minimum spanning tree is. It is basically a tree that connects all the different nodes. You may have this kind of nodes with more than 1 or 2 degrees. But anyway, it connects them so that the minimum links are used. So no outliers, everything is connected. And no cycles, it's a tree. Now, what was your name?
Hadrian.
Hadrian. Okay.
Yes.
Yes. What Hadrian was kind of talking before is that in this kind of configuration, I don't know if you heard it, but he said the word obvious. Obvious is very bad word. Like if you write research, it's why is it obvious? This might explain it. If the relationship between minimum spanning tree and traveling salesman, there is some relationship there. In this case, the minimum spanning tree has no branches. It doesn't really matter how I put the targets here, if they are going to be in a line maybe or in a circle, but if this minimum spanning tree has no branches, I think that Hadrian is still going to say it is obvious.
No.
No, so this is not obvious.
Oh, no. Yes, because it's like a line.
Because it's like a line. But I'm kind of thinking that you're using the word obvious, but you're not exactly sure what makes a game obvious or not. It's like a line or it's like a circle. Is it about the shape or is it about the relationship between the nodes?
More relationship between the nodes, I think.
Yeah, that's...
Yes, I think the idea you already told it. It's more nodes with more than 2 links you have in the minimum spanning tree. Harder it is to recognize the travel segment problem.
Yeah, I mean to somehow see the solution.
Yeah.
Yeah, I agree with that. So for example, maybe this one is not obvious anymore. I mean, okay, now you see the spanning tree, but even if you see it like this, this is the optimum solution for the TSP. And MSD has also those other links, so they might also affect your decision somehow. Okay, this is not the only factor, the spanning tree. So now we're getting a little bit even closer to what you were saying before. Sometimes like now, you can still say that, okay, maybe this link is the longest, but because many of these nearest neighbor distances are similar to each other, people, humans, become worse at seeing where the small differences are. So computer has no problem noticing an extra pixel here, but human starts to get a little bit of a problem there. Anyway, this was a bit of a sidetrack, but you can easily make a complexity function also based on this. So we are experimenting with this kind of complexity function where we just count the nodes that have branches in the minimum spanning tree. That's it. So this would have a complexity of 2, while this one has a complexity of 0. I don't know if it is a good function, but it's an alternative function. And if you want to know what people are going to find difficult and what not, the only way to do it is to have them try to solve the games and see if it correlates or not with any of these functions. So if you want to find out for this real application what would be a hard game scenario, you need to have many people playing, try out different complexity functions, and see which ones the playing times and their correlate and their and the complexity measure is correlating or not. You can even consider multiple and combine them, maybe even using some machine learning algorithm. Like try to find some way of combining different complexity measures to get highest match with what people are actually experiencing. So many things are here that we haven't even done yet, but it's interesting topic. And there are many papers about in psychology about this problem and how some people try to solve it and so on. Okay, so yeah, it may look like simple problem, just find the targets there, but analyzing it, defining game instances and seeing where do people actually put a lot of mental effort, where they don't, is not easy to answer, and we don't have a best solution yet. Algorithms are separate, so we have this page where we can load similar kind of list of games. For example, this is the side test game from 2016. And all these things on the top are different algorithms. So we have ant colony optimization. This one is taboo search. This is some greedy, seems to be same as this taboo result. This BB is branch and bound, and this guarantees optimum for the given targets. It took also a little bit longer to calculate. And there are also some other ones here. I'm not going to go in that much detail. But you can see that not all algorithms give you the correct answer. So these in the beginning, they are heuristic algorithms. They will try to lower to optimize as much as possible, but they have no guarantee that they will reach the optimum result. Sometimes if you have very many targets, you have to use these algorithms, otherwise you will wait maybe even a year to get your result. Think about, I don't know, postmen and delivering things all over Finland, and every address has to be taken into account. You will not have the perfect solution, but you will still have probably a pretty good one. there maybe you take some hierarchical approach. You take each city in separate, and then consider cities as nodes, and then once you visit the city, you zoom in, and you check all the addresses there, and so on. Of course, that's actually a little different problem because you have usually multiple postmen, so it's this KTSP problem. So multiple people starting to do their job in their same time, but very related problem anyway. Okay, and quite important what Hadrian was saying before is this, let's see, where was the other example? Yeah, there is also this option to use roads or not. So, oh, okay, this has to be some bug, I think. Refresh. Okay, better. Even though it has some errors here, so yeah. People are constantly working, I think, on this page, and unfortunately, O-Mopsi doesn't have this production environment like Mopsi has. So, if somebody's working here, bugs or problems are going to appear instantly on the actual consumer version, which is a bad thing. You should never do that. I think this was done because at some point O-Mopsi was considered like, okay, it has enough things and we don't develop anymore, but I don't know the reason. So you should always have a separate environment when you're doing the testing, and don't let your customers see these kind of problems in real life. Okay, and this roads feature. So all of these algorithms are going to get as an input a distance matrix, a pair of distances between all the targets in the list. So basically this is target 1, this is target 2, and this is target 3. The matrix is just going to be something like so the distance between 1 and 1 is 0 from itself from it to itself. From 1 to 2, maybe this looks like maybe more, but anyway, so 1 kilometer. 2 to 3, this looks like 1.5 maybe. And 1 to 3 is, I think this looks like 2 kilometers. Okay, and again 2 to 2 is 0, and 1 to 2 can be, or yeah, can be the same as 2 to 1. So this is a 1, and of course this is going to be filled in everywhere. And all of these algorithms are working with this distance matrix. Now, if instead of computing the straight distance between the nodes, you're going to calculate the distance using some constraints, like a road network, you can still use the same algorithms, but the input is going to be different. And this is what happens when we put these roads on there. So it's not, yeah. Yes. Okay. So apparently this is now the optimum solution with the roads on. Has it changed in any way? No. It still has the same kind of connection, I think. Like, seems to still go to the same orders, but but this is not necessarily the case. So. Okay, this is also similar. I think this might be some.
Also, the distance is the same.
Sorry?
The distance is the same.
Oh, okay. Probably some bugs. Okay, so distance maybe has some problem there. Okay, this is now some very interesting thing here that you have to go apparently here and then back again. I'm not sure why it is not just going this way somehow. I mean, I would expect that these roads...
So, no way. I'm not sure, but you can reach the target from only... Oh no, okay. Yes.
I'm not sure. It's a bit strange. It could also be that, now this is another problem, it could also be that the database we use to calculate this routing is old. So OpenStreetMap, Google Map constantly update visually here the things if they build a new, if somebody builds a new road or if some road is destroyed. And I think we have the data from 5 years ago for the routing. So this can also be a problem if, for example, here some new connections appear. Okay, but anyway, many problems and yeah. Not obvious how to handle all of them. We do try to handle all of them, but it's not clear if we have the right solution or sometimes even if we are on the right track. Other things we take into consideration is accessibility. So there is also this button here. Yeah. I'm not sure if we have any games with problems, because if we do have, we probably fixed them already after we got this feature. But the idea here is quite simple. So what is an unaccessible game? It doesn't mean that you can play it if you are disabled or something like that. It means something else in our case. Okay. So think about the following situation. You have maybe a river here, and maybe a game is generated so that you have a set of targets here and one target there. So this game is going to be problematic for the users because they need to cross the river in order to find the target on the other side, or targets on the other side. Of course, there may be some bridge somewhere that you can cross the river, but even then you are going to have in your playing something that looks like this, which is not fun. You're not going to find any targets along the way. It looks like an unreasonable thing to do. It looks like an extra distance that shouldn't be there for the gameplay to be nice. So this is what I think Nancy was calculating to see if the distance between some pair of targets is going to be significantly different than the same distance but using the road network. So if the way to go there according to the context, to the road network is much longer, maybe like 2 or 3 times longer, then that game has a problem or more problems inside. So this accessibility is also something we have to check out, because it's not always obvious to the people who are creating the games. So some kind of automatic measure is needed. Of course, here you can also consider these other problems, like is the area free to access, and are you allowed to go there? Was this, what is the holiday called? What are the 2 holidays in Finland? Is Juhannus is one, but the other one is spring at some point. Is this with V maybe? Vappu. Oh, okay, yeah. Okay, yeah. Pasi made at some point this Vappu game, and I tried to play it. But at the moment when I played the game, there was this one target here with the horse track. And this target, originally the location was in the middle of the horse track. And in that day when I decided to play, there was a race. So I couldn't go there. Usually it's free to go for everybody, but he put it there and didn't think much about it. So you can see here my trajectory was really trying to get that target somehow, and I actually failed. Then I went home and I hacked the database, like I want to have the finished game. So I put the target some way on my route in the entrance of the horse track. But yeah, so these kind of problems, very big, very common problems. Are places accessible? Are they accessible all the time? Do they have restrictions? And do they even exist anymore? Is this horse track still there? The game, I played it in 2014, maybe they decided to make a shopping mall out of it, or I don't know. So recency of the data, accessibility of the data, is it available still? These are quite big problems in our case, and we are trying to figure out solutions for all of them. But it's not easy. Recently we are trying to look at Twitter feeds to see if anybody is talking about some specific target recently. Like, is anyone talking about horse track race or things like that? So basically natural language processing, but we haven't looked that much into it yet. So, yeah. Of course, you could figure out some problems even from users' trajectories. So here this trajectory shows some strange behavior. Again, I'm using this kind of adjective that I shouldn't use, like Adrian before. What is strange here? They are points. Why is it strange? But anyway, it intersects, it maybe stays too long in this location. It has this long loop where no new target is found, so maybe some of these features could be strange. Combination of that, but yeah. Okay, it seems like it seems like Jukka played in the same day as me, but probably he was able to go inside the place at a different time. So at 8 in the morning, I think he didn't have the problem. Okay. About game creation. So how do you create a game in O-Mopsi? Actually, anybody can do it. So you can make your own instances if you want. but the game creation is not extremely simple. So I will explain a little bit about how it goes. So the interface, I think, needs some work. You need a Mopsi account. And then you have this own games section. We are experimenting with some automatic game creation, but it is still very far from producing decent games. So I think that, yeah, I think this one is the automatic one. You give it some length and some number of targets and maybe keywords, and it looks, oh, did I do? Did I press something bad? Okay, I guess it did find some targets here. Okay, I think I pressed many times or some strange behavior happened and now it's generating multiple games. Yeah. So this car probably is not there anymore. So now we have the recency issue. This sign may be there, but probably has some different text on it. So also similar problem. This is not clear what it is. So image has some issue. It's somehow the target that you are supposed to find is not clearly defined in the image. This one could be a good target. So it's most likely still going to be there. It's easy to identify, and yeah, so this may also be a good target, but I think that probably this, yeah, this, just a second, this graffiti is different, but the bridge or whatever is still there. Yes?
Yeah, it's also an idea for the complexity, how hard it is to find the target.
How hard it is to find
Yeah,
the
because
target.
you just show the board of Kataya with some papers in, but if the papers are the same, maybe people will look around and will not think about it's the target.
Yeah, okay. Good point. So
But
basically the targets may look differently depending on something.
yes,
It may look differently even depending on the weather. Like the tree, a very luscious tree may look very boring now when it's when no leaves are there. So these kind of things, good point. So property of the target, how recognizable it is.
yeah.
This goes into image processing and we haven't done much of that. We have used some existing components that analyze images and extract keywords from them. Try to figure out if automatic content extraction from image is able to identify clearly some object there, like for example, car. Then if automatic method was able to identify a car there, it's probably a good picture. It probably has something there. Automatic method may say something like green or I don't know. Oh, sorry, I'm always behind the pictures that I'm showing. It may just say something like forest or green or or some building, but I don't think it can recognize building just from that. So this is vague what person is looking for. Oh, I don't even know what these are anymore, and I think I have to refresh. Okay, but the automatic method we rarely use it. So what we usually do when we create a new game, is we do it manually. Where are my tools? Okay. Something broke. Okay, great. There should be many tools here on the top that that allow me to do stuff. But I think it doesn't. Yeah, probably can't demonstrate this. But I can still give the idea of how it works. So, if you remember from O-Mopsi, sorry about that, but if you remember from O-Mopsi, we had this recommendation feature that was showing things on the map. There was a very similar thing that was querying the data in the area, but once you opened the target, you had a big button there saying add goal, so you can add the target into your list of visitable targets. There is also option to upload a target. If you have a picture of something, just upload the picture and fine-tune the location with the marker. So manual editing is needed. And this manual editing is needed surprisingly a lot. For example, this picture here, okay, let's say that this picture is in O-Mopsi, right? Somebody took it, it's in the O-Mopsi database. It has location, it has the photo, it has even the title here. Is this enough to put as a target? It looks pretty good because it's somehow this tree that is separated from all others, so it's almost clear what we are talking about here. And the title, the pictures in O-Mopsi also have a text description. So this means spruce, I think, in Finnish maybe. Anyway, so let's say that this target is okay. The small issue is that the user who took this picture was not at the tree when he took the picture. His location is actually probably 20 meters away from the tree, because he had to be able to capture the picture in there. So even this is a problem, fine-tuning the location of where the picture was taken from and where the object is. If you remember our app developed here, this Where is O-Mopsi game, that has so few difficulties compared to this one. But we have several reasons for keeping the pictures at the target location. Reasons are, person sees it and then he can play basically with the phone in his pocket if he knows the area, if he's playing in a familiar area. This has advantages for safety. Looking at your phone all the time while cars or whatever are coming is not something that you want to do very much. We also have sound-based navigation in the game. So as you are approaching the target, you start to have these beeps, like maybe every second or every 2 seconds you have a beep. And as you're getting closer and closer, the frequency is going to increase. So it's kind of like this metal detector kind of thing. If you hear these kind of noises, then they are probably outside. Somebody's probably playing O-Mopsi. Also related to safety. So you look at the map once, you have a general idea where you are supposed to go, and again you can put the phone in your pocket and just go there without constantly looking at the screen. You just listen to the feedback that it's giving you. If the beeps are becoming less frequent, it means that you made a mistake. You're going in some other direction and you should look at the map again. So many of these small problems must be considered, and this could be added also to that game we developed in the class. Why not? So yeah. One more thing is that, okay, another reason for why you want as little interaction as possible with your device, weather conditions. If it starts to rain and the device gets wet, it's not going to be responsive anymore. You're desperate for it to respond fast, maybe running or whatever. You don't have the patience to stop. You may do mistakes when you're quickly panning the map around. You definitely don't want to press the cancel button, like give up by mistake. We tried to make it harder to access that button, but anyway. So usability issues, many of them when moving of the users has to be taken into account. So they will be moving. When they look at the map, they most likely are not going to stop. They are still going to move because they think it's in the right direction and they don't want to lose time. So think that your target audience is going to be users that are moving. They don't have the patience for that. The interface should show them what they need to see at the specific time. And if possible, not even look at it anymore after they decided where to go. So, small tips there. Okay, but I think that this is more or less everything I wanted to talk about. Some of the features didn't work, unfortunately, but they probably will start to work again after a few days. So in O-Mopsi, at least Lahari and Nancy are still doing things in our group, and some things are still appearing there. So if you have questions, we can move to those. We can talk about anything related, and if not, then we can also end sooner today, because I have taken time in other lectures without noticing.